vibrant energy creators, weaving solar technology into every sunlit surface. Our cutting-edge materials turn facades into micro power plants, blending efficiency with aesthetics. As the world's largest building integrated photovoltaic manufacturer, our Ontario plant crafts over 25,000 square feet of sustainable materials daily. From design to installation, Mitrex powers a brighter, greener tomorrow. Join us in shaping the future.
Hi, everyone. Welcome to our LinkedIn Live BIPV presentation. Before we formally begin, we're going to allow just a couple of minutes to let people get on, and then we'll begin. I suspect that since the FIFA World Cup just started at 3 p.m., we might have a few late stragglers on. So be patient with us while we wait for those to join us, and then we'll go live. Thank you. Looking over to our trusty producer to see if everyone's coming on. How are we doing, Malcolm? All good. Good to go? Excellent. All righty. So hi, everyone, and welcome to our LinkedIn Live BIPV in action at the University of Toronto, Myron and Berna Garron Health Sciences Complex in Scarborough, Ontario, Canada. I'm Terry Oswald, and I am very excited to have you with us today as we dive into this groundbreaking project. So this LinkedIn Live is the first in a two-part series covering our latest project. This episode takes you behind the scenes of the solar cladding installation process, while the second will showcase the completed project alongside an in-depth look at the building's design. So today's program includes an on-site tour of the new building that's being completed at this moment, a presentation that can be accredited with AIA credits, and an interview with Andrew Ligori, who is the Senior PM from EllisDon, the project's general contractor. So we're also going to take a closer look at Mitrex's building integrated solar solutions and wrap up with a Q&A with myself and Corey Fry, our Director of Sales. A Google form will be available throughout the event to collect your information for the AIA certificate, to sign up for our marketing package, or to request any specific samples. So please keep an eye on the comment section, as our team will be dropping the link there. Also, the form will be available for 15 extra minutes on the description of this event, so you can fill it out once the event is completed. Besides, we'd love you to drop by any questions in the live chat so we can answer them during the Q&A. So let's get started. First up, let's join Corey Fry, our Sales Director, live from the site at Myron and Berna Garron building. Corey, how are you?
Hey, I'm great. Thanks, Terry, and thanks everyone for joining me. As you can see, I'm here live on site at the University of Toronto Scarborough campus, and I'm in front of our project here, the Myron and Berna Garron Health Sciences Complex. As you can see behind me, our guys are working hard and working diligently to make sure that this project gets completed on time. The building you can see behind me, of course, is the Myron and Berna Garron Health Sciences Center. And as you can see, our Mitrex panels are being installed as we speak. All of those gray panels you see on the side of that building are all clean energy generating Mitrex BIPV panels. This is actually a good angle of the building because you can see a few different stages of the installation. So our panels are installed here on a fairly typical rain screen installation. You can see there it's a thermally broken clip and girt system with mineral wool insulation in between the gaps in those girts. And then our BIPV panels installed over top of that system. There'll be a total of 63,000 square feet of Mitrex BIPV panels on this building. Combined with a standard rooftop solar array, there's going to be 420,000 kilowatt hours of annual electricity generated from this building. It's a beautiful day here in Toronto. again, things are moving quickly here at the site. While I'm here, I'd like to thank our partners on the project, EllisDon, the general contractor, of course, Diamond Schmidt and MVDRV, the architects on the project, and Synergy, the engineering consultants on the project. So with that, I'm going to throw it back to Terry in the studio, where she's going to share some more information about the project.
Wonderful. Thanks, Corey. So now that
Terry.
you've seen the building on site, I'd like to take you behind the scenes to show you how it all came together. Please note that this section is also eligible for AIA credits. And after that, we'll hear from Andrew Ligori, Senior Project Manager at EllisDon. And before wrapping up with Q&A, so be sure to stick around until the end. Submit your questions in the chat, and don't forget to request a marketing package. Okay, so for those of you who aren't familiar with Mitrex, we are a Toronto-based manufacturer specializing in cladding materials, including building integrated photovoltaics, or BIPV. BIPV is a technology that combines a building's exterior facade with solar technology, so it looks and functions like a normal wall while producing energy. We're very proud to be the world's largest BIPV manufacturer with more than 25 years of experience in cladding and construction. Behind me is our advanced manufacturing facility, capable of producing 25,000 square feet of solar material every single day. Our team of architects, engineers, and project managers supports every stage of a project, from feasibility studies and energy modeling to full turnkey solutions. We work very closely alongside project teams to deliver systems that meet their unique goals and constraints. Our journey started in 2003 with GCAT Group and continued in 2014 with Cladify, where we pioneered lightweight cladding solutions. In 2019, Mitrex was founded to seamlessly integrate solar technology directly into building materials. So far, we have installed over 25 million square feet of facade materials across more than 700 projects, with another 1.6 million square feet underway. Last year, we set a Guinness World Record for the largest BIPV solar mural. At Mitrex, we offer a full suite of envelope solutions, from solar cladding and solar railings to solar glass and traditional non-solar facade systems. Our solar cladding systems like eFacade Lite, eFacade Pro, eFacade Pro Plus, and our newly offered eFacade Tilt come in a wide variety of sizes, colors, finishes, and even projections, so you can match that vision for any project. Our solar railing systems replace conventional systems, and our solar glass can be used in IGUs, window walls, and curtain walls. Our traditional cladding materials include stone, brick, porcelain, aluminum, as well as prefabricated and large format systems. So this learning program is registered with AIA CES for continuing professional education. By providing your AIA number in the form, we will upload your attendance and register you if certification of completion is needed. Make sure you check off the form, and someone from Mitrex team will email you upon completion. Today's session will focus on designing with building integrated photovoltaics, or BIPV for short, as you'll hear me reference throughout today's session. We'll start with a quick summary of the basics of solar and its key components, move on to current BIPV technology, and how it's evolved with design and performance in mind. Look at methods of incorporating photovoltaics into existing and new construction to maximize and hit sustainability targets. So let's talk about the basics of how solar energy is created. Solar energy originates from the 19th century, where scientists first observed that sunlight could generate an electric current. All light contains photons that carry energy proportional to the wavelength of light. So when a wavelength of light hits a surface, that surface absorbs some of that light energy. And with enough energy, the surface releases electrons, which result in electricity. Materials that use this are called photovoltaics, PVs, or solar cells. As far as the BIPV system components, it is the same as a standard PV rooftop array or a solar farm array. The only difference is that PV is on a vertical application. The panels are connected into strings through pigtail connections from each panel, which will then feed into an inverter, which converts DC to AC energy. String inverters are most commonly used in building applications. However, for smaller systems, microinverters can also be considered. Other electric components of a BIPV system can include optimizers, which limit the effects of shading, transformers, which harmonize the electricity generated by the BIPV system with the utility grid, and bypass diodes, which can be used to monitor a singular panel's performance, and monitoring software, which can provide energy generation data for the system as a whole in real time. Here's where BIPV tends to have the biggest impact. It's especially effective on projects with large facades and where sustainability is a key goal. Whether that's meeting ESG targets, local mandates, LEED certification, net zero goals, or simply committing to environmental stewardship. But BIPV isn't just about sustainability. It's also efficient to install, it's low maintenance, and built for long-term energy performance, making it a very strong fit for both new construction and retrofit projects, particularly across high-rise residential, universities, healthcare, airports, and other institutional sectors. The Myron and Berna Garron Health Sciences Complex is the largest BIPV structure in Canada. This building represents the highest green standard for the University of Toronto, aligning with their roadmap for innovation. A design that included over 3,000 BIPV facade panels resulted in a transformation of the building envelope into a clean energy generating facade, seamlessly integrating renewable power into the architecture. From the very beginning, Mitrex was embedded in the design process, working hand in hand with the project team to bring the vision to life. Our schedule was carefully coordinated with window suppliers, landscapers, and other trades to make sure every single piece of this complex puzzle came together seamlessly. We also had electrical system and building envelope consultants involved throughout. One of the more unique challenges we tackled was integrating BIPV into the sloped areas of the building, something that required close collaboration and creative problem solving at every single stage. The system uses an aluminum honeycomb module with an interlocking channel, an open joint cladding approach that also incorporates the air vapor barrier. Because this building has a lot of varied shapes and complex corners, much of that geometry was pre-assembled before it ever hit the site, which kept the installation clean and efficient. We also partnered with our sister company, Cladify, to supply aluminum and honeycomb materials in the areas that called for it. And while we used Mitrex certified installers on this project, the system itself follows international standards, meaning any qualified installer can work with it. The University of Toronto has set a very ambitious goal to become climate positive by 2050, going beyond carbon neutrality to actively remove more greenhouse gases than it emits. These efforts have earned U of T recognition as the most sustainable university in North America. The integration of BIPV panels supports the campus expansion with a sustainable approach. It provides a renewable energy source that meets sustainability goals by generating a 632 kilowatt system, producing approximately 420,000 kilowatt hours per year. The U of T's commitment to sustainability is ultimately a commitment to the health and well-being of the people who live, work, and learn on its campuses by working to improve air quality and reduce the environmental health risks that affect students and faculty every single day. 632 kilowatts doesn't just sound impressive. Let's put that into perspective. So that's enough power, that's enough to power 50 to 60 Canadian homes simultaneously for an entire year. Keep an electric vehicle charged and on the road for 250 years. Or brew 42 million pots of coffee to keep the students awake. It's enough to light 1,000 streetlights continuously for 47 years. Power 10 hospital operating rooms nonstop for 7 years, or run 100 university classrooms for 8 years straight. All of that from one building generating clean, renewable energy every single day. We're proud at Mitrex to operate the world's largest BIPV factory, equipped with fully automated, cutting-edge technology. We have achieved an A2 fire rating, and our products have passed other tough certifications like NFPA 285, UL S134, IEC 61730, IEC 61215, plus Miami-Dade County hurricane testing. All of this is backed by a 25-year warranty covering both product quality and energy performance. At the SAMI project, the panels were installed using a conventional rain screen system. This keeps air pressure balanced, prevents water intrusion, and allows the building to breathe. The system works for both new construction and retrofits and can be installed as stick-built or prefabricated, keeping installation efficient and straightforward. For the electrical design and installation, our in-house engineering team supported the system layout. After the panels are mechanically installed, the electrical system is configured like a conventional solar installation with standard components such as DC optimizers, inverters, a panel board, and a disconnect switch. The system supplies energy for on-site use, with excess power exported back to the grid. Real-time monitoring software enables continuous performance tracking. To round all of this out, this project illustrates how architecture and technology can work together to create meaningful impact. It's not just about adding solar panels. It's about designing a building that performs beautifully and sustainably for decades to come. Through BIPV, this project sets a new standard for sustainability leadership, enhancing energy resilience, lowering long-term operating costs, and aligning with the next generation of green building standards on the path to net zero carbon. The vertical BIPV panels are more than functional. They are an intentional part of the building's expression, merging form and function in a way that redefines what solar architecture can be. Embedding sustainability into the building also empowers students with the knowledge and agency to shape a healthier future, while the university's recognition as the most sustainable in North America signals that those who study and work at U of T are part of an institution that genuinely prioritizes their long-term well-being alongside the health of the planet. So thank you for sticking out with us. Now we get ready. We're going straight to the source. Andrew Ligori, Senior Project Manager from EllisDon, the project's general contractor, is here to walk us through the project and give us an exciting up-close look at the BIPV installation.
Welcome, I'm Corey Fry.
Sorry, don't forget to fill out the form to get your AIA certificate. Get your Mitrex marketing package or order a specific sample. Just fill out the form that's being shared in the chat.
We're here at the SAM-IH, Myron and Berna Garron Health Sciences Complex at the University of Toronto, Scarborough. I'm joined with Andrew Ligori from EllisDon, project manager on this job site.
Hello.
And Andrew, I'm just curious about, if you could tell me a little bit about the overall goals or vision of this project.
Right, so good morning. The overall vision of the SAMI project is to create a community-focused hub for health education that trains diverse local workforce to address the healthcare shortages in Scarborough and Eastern GTA. So it basically aims for an inclusive excellence by fostering collaboration between medical professionals, researchers, and community members in a sustainable, healing environment. The goal of the project is to create an integrated care hub that connects the university with local institutions, providing a central point for training and for clinical care.
That's right. Can you tell me a little bit about what your experience has been like working with Mitrex so far, and how it's been integrating BIPV cladding into this project?
Yeah, sure, Corey. So this is a design build project, CCDC 14 project. So it very much requires a lot of collaboration up front. There's many joint meetings to review design details and basically on how to approach the execution of the project together with the design build consortium. So the experience was positive despite the challenging details. As you can see, there's quite a lot of complicated geometrical design challenges, and of course the schedule. So yeah, it's been pretty fun.
Can you tell me a little bit about what influenced the decision to integrate BIPV technology into this project?
Yeah, sure. So the University of Toronto Scarborough has a tri-campus energy charter standard that requires essentially all new construction projects to meet the project-specific energy performance targets and budget established in the Sustainability Project Charter. So it's very much a performance-driven output spec that we are required to meet.
So have there been any particular new challenges that you've come across installing BIPV on this project? Maybe something that you wouldn't encounter with traditional cladding, and if there was, how did you overcome those challenges?
Yeah, so for sure, definitely a unique set of challenges. The interfacing details, the building interfacing details were quite challenging. This facade back here is about 55,000 square foot open joint rain screen cavity system. So with that comes some unique challenges with maintaining the air barrier and the backup rain screen system. So the facade was designed by Diamond and Schmidt Architects in joint collaboration with MVRDV. And we have basically 4 unique colors and 2 different finishes on those colors, a satin and a gloss, plus 1 wood tone panel. So the panel sizing varies. There's probably 30 plus different versions of a panel sizing, which all belong in a certain space, and the design is sort of a geodetic type layout. So yeah, alongside with Mitrex and EllisDon, we retained a third-party envelope consultant that works for EllisDon. They were synergy partners who've done a very good job working alongside the installation teams to review all the interfacing details and to ensure the install performs over time to the required output. And we also meet 2 times a week for what feels like very long, but it's probably been 2 years, maybe more, maybe almost 3. Basically collaboration between all parties involved to just review pretty much every single detail upside down and inside out of the project. So overall, what are your expectations for the performance over the lifetime of these panels? Right, so the technology is a bit new to the market, but the project basically has a manufacturer's warranty on the panel performance being built by Mitrex and the solar photovoltaic cells within each panel, which is basically a 25-year warranty from the date of substantial. So it's expected that the panels should be at least 80% minimum rated power output by year 25. And of course, the delamination of the panels is covered by a lifetime warranty given by Mitrex. Warranty given by Mitrex.
That's right. So after the completion of this project, you mentioned, that BIPV is not widely used yet around this market.
No.
How do you think a project like this one is going to influence the adoption of BIPV on future projects similar to this one?
Yeah, good question, Corey. So obviously, following the completion of the SAMH project, we foresee many new proposed projects in the GTAH adopting the similar BIPV technology. It's very new to the market. The selection of the facade is still very unique in the market, so there's really no other project currently like this, which is very exciting. And the industry, I think, still needs to evolve, but there's certainly piqued many people's interests, I think, and many building envelope organizations and consultants and architects alike. So I think we're definitely going to see a lot more. There's a lot of eyes on the project, and yeah, hopefully we're optimistic the technology is here to stay forever, I think. And most likely, you know, the new projects being proposed in the city and on Ontario, throughout Canada, will probably incorporate some element of BIPV facade and certainly roof PV in their designs.
So far, Andrew, are there any valuable lessons that you've learned working on BIPV on this project that you'd like to share with the rest of the industry?
Yeah, probably there's a few for sure. I would say establish clear goals and expectations early on from all parties, from the client as well as yourselves and EllisDon and everyone, the contractors, is for sure. Establish clear performance targets. That's very important, and I would definitely suggest that everyone models in the theoretical realm all of the output of the cladding system, particularly with respect to linear transmittance and thermal clips and the analysis of how each component performs, and then sort of model it together with an overall system so you can guarantee your output. Definitely important. I think investing up front in the design coordination, flushing out as many details as you can, and basically don't leave any stones unturned with this type of system. You pretty much can model everything in 3D world now, which we did on this job, and it's proven quite beneficial and fruitful for the team. I think mock-ups are another really important part. It really works to flush out all the interfacing details as early as possible, even early on in design. That just allows really the teams to wrap their head around some unique interfacing challenges and essentially just eliminate any rework or any proposed deviations when it comes time to execute. So I think overall it helps the design teams in executing the build, and of course it helps us stay on schedule. So
what has the shareholder feedback been from other stakeholders in the project, like the university or the future tenants, about the overall integration of BIPV cladding on the project?
Yeah, good question. So obviously very unique. I think the University of Toronto is probably one of the best ownership groups to work with, and to push the envelope on new design technologies and incorporating that within their buildings, not only in the University of Toronto Scarborough campus, but Mississauga and of course St. George. So you really need a good champion, I think, that supports this. They're quite pleased, I think, overall, and so are our design teams. So we're quite happy, and of course, once the building comes to fruition, I'm sure there'll be many other stakeholders that tip their hats off to us. So, yeah.
So what are the next phases and the final phases for this project? I know we're nearing completion. What do those final phases look like, and how is BIPV contributing to that?
Right, so the project behind us that you see is probably about a month to a month and a half away from being fully done, completed, and panels connected. So we're all very much anxiously waiting for the connection of the panels, and essentially it's very similar to waiting for a Christmas tree to illuminate close to the holiday season. It brings quite joy to the team, so we're obviously very eager for it to come to life, given all the hours and hard days and effort given by many people. So yeah, I think we're all very excited about what's to come, and look forward to having a completed project soon.
Fantastic, that's great. Thanks very much for your time.
You're welcome. Thank you. Bye.
Wow. That's amazing. I feel like a kid at Christmas myself. Okay, thank you, Andrew. What an incredible look at this project. So now we get to go into our Q&A portion and discuss any questions you have about the technology or the design. And if you haven't already, feel free to post your questions in the live chat. Once again, please welcome our sales director, Corey Fry, who is live from the job site. How you doing, Corey?
Hey, still good here, Terry. It's hot out today. I'm sweating just standing still here.
You know, I'm just relieved that it's not raining. We were worried it was looking pretty dark there, so thankfully that worked. So we got some questions. You ready?
Yeah, let's go.
All right. So question number one, how do the panels differ in appearance if you have panels for energy production versus panels without energy production? I'll answer that one. They don't. And we are very proud to say that when it came time for our mock-up, we had the good folks at both architecture firms, Diamond Schmidt and the folks from MVRDV in the Netherlands. They came and they were looking at them and they couldn't tell the difference. Once we revealed the wiring in the back, then it was clear which ones were live and which ones weren't. But from an aesthetic perspective, you haven't got a clue. There's no way that you would know which ones are generating and which ones are not. Question number two, do you see demand for low profile junction boxes to improve architectural aesthetics? What do you think, Corey?
That's a good question. Demand for low profile junction boxes. I mean, I suppose there could be a demand for that, although it's not something that's really come up in conversation since I've been started working with this BIPV material for about 5 years now. You know, the panels are relatively low profile themselves anyways. I assume there's always room for any construction material for that matter to reduce its profile and get smaller and get sleeker. So potentially yes, but in the same breath, you know, the junction boxes aren't very big. They don't really impact the profile of the panels that much anyways, especially these ones here with the aluminum honeycomb. The depth of that aluminum honeycomb panel is quite a bit deeper than the junction boxes anyway. So reducing the depth of those junction boxes wouldn't reduce the profile of the panel overall.
Agreed. Great answer. Are you seeing more demand from new builds or from retrofits right now? That's a great question. And you know what? We are experiencing both. A lot of new construction and a lot of retrofits because it is a lightweight cladding solution. It's easy to work with, but especially with retrofits, what better way than to give a building a facelift by using something that will improve thermal performance and is super lightweight. You're not adding extra weight to the building. You're talking about 5 pounds per square foot. So it's very, very easy. And so quite honestly, the interest is, I would say at this point, is equal from both new construction and retrofits. And I think Corey would agree that a lot of his projects as well are very similar, yes?
Yeah, that's right.
For sure. Okay. Some parts of the building were built in a factory before arriving on site. How do you decide which parts get built in the factory versus which part gets put together on site? That's a great question. I think Corey and I can both answer that equally by saying those are not decisions we make on the fly. Those are all decisions that are made long before anything gets to site. So our designers and our engineering team sit down and go over all the details of the project and determine which ones need to be prefabricated at our facility to arrive on site ready to install. And that's for both reducing expenses, obviously keeping costs down and improving time and efficiency. So any decisions that are made on prefabrication are always with both those purposes in mind, reducing expenses and improving time efficiency. Okay, for BIPV projects, do you prefer integrated junction boxes or external junction boxes for maintenance purposes? Good question. What do you think, Corey?
Say the question again, Terry. Integrated junction boxes?
Do we prefer integrated junction boxes or external junction boxes for maintenance purposes?
Well, I suppose it depends on the type of junction boxes talking about, but I mean, I can talk a little bit about the overall system in general. Things like inverters, for example. We use string inverters almost always instead of microinverters. Terry touched on it in her presentation earlier. And that's because, you know, if there's ever a time down the road where inverters need service or need to be replaced or those kind of things, if we have microinverters behind all these panels here, it's a little more challenging to access them. So from that standpoint, things like inverters are using string inverters and kept outside of the system. I suppose the conversation would be similar for things like junction boxes. It's really about ease of accessibility. So integrating them into, areas behind the panels isn't always that easy to access. So keeping, those electrical components of the system outside and easy to access if they ever need to be serviced down the road is always preferential, just for the efficiency of that service.
Gotcha. In the SAMI project, Mitrex had to work alongside window installers, landscapers, and other construction teams. How does Mitrex typically manage and coordinate with other trades on a job site? Good question. You want to take that, Corey?
Yeah, I mean, it's important that we're coordinating with all of those different trades. The window trade that you mentioned is very important. Of course, those windows are lining up right next to our panels. So coordination is really important, especially for sizing, placement of those panels. Once the critical lines are established on this project, it's important that all the trades stay on those critical lines, especially for the active Mitrex panels, which aren't size adjustable once they're on site. So if the windows are out and the spacing is different from what we see on the final shop drawings, obviously that's going to create problems on the site. So that coordination is important, especially with the window trade. And then of course you can see here some of the boom trucks are in areas where maybe the landscapers would be working in the future. So with them, it's a lot more about scheduling and the timing of when our trade finishes and when they come in and do the landscaping afterwards.
Absolutely. And of course, all of those are done way in advance. So all of those details are covered. Does the project have battery storage? It does not. So essentially all of the electricity that the building generates on a daily basis is consumed by the building on a daily basis. They don't have battery storage, not to say that it's not available. It's certainly something that we can provide if a project requires it. I think Corey would agree that in both our collective experiences, battery storage is not a very popular request, but it certainly is available and that can be integrated into the project very easily. Does Mitrex help with estimated energy production calculations based on an architect's design? It certainly does. So what we do very early stages is take all of the elements that affect the design. So we take shading into consideration, we take geographic location into consideration, we take building orientation, selection of color, because different colors will produce different power outputs. So once we really understand the project and have all of that information, we take all of that information, put it into a system which allows us to get a very accurate estimate of how much power that building will produce. And also taking it into account that all elevations can be looked at. The south is the most common, and a lot of people think that's the only side, but really east and west are very strong performers. And the north side works on reflected light. So we actually will calculate the north side as well, if it makes sense. So once we get a good look at the overall picture, then the architect and the client can decide, let's stick with the south, or let's do the south and the east. The SAMI project is a great example of how all four elevations are working in concert to produce electricity. So if it makes sense, then we'll look at all elevations. But certainly we have very particular ways on how we estimate that power production. Are there any regulation changes at the Ontario provincial level that could be made to make it easier to implement BIPV? As Mitrex works in many regions, is there policy in other regions that have been beneficial that you would like to see replicated in our province? Interesting. Well, Corey, what do you think? I mean, we have our, incentives, which are a great thing, but regulation changes, I'm not quite sure how to answer that one. What do you think?
Terry, sorry, I had a quick audio gap there. Can you just repeat that question real quick for me?
Absolutely. Are there any regulation changes at the Ontario provincial level that could be made to make it easier to implement BIPV? As Mitrex works in many regions, is there policy in other regions that have been beneficial that you would like to see replicated in our province?
You know, in all honesty, I think our province does a really good job. Federally, there's the clean tax investment tax credit. The clean tech investment tax credit available in Canada, which is a very significant incentive for projects integrating solar technology. I guess if I wanted to see any changes, there are a few other, you know, auxiliary programs out there, incentive programs that do give incentives for solar energy. However, they're more reflective in the traditional sense that it's just for panels on the roof of a building. And sometimes not all of those systems will allow BIPV cladding or things like BIPV balcony railings to qualify, because the verbiage specifically refers to rooftop solar, or things like to meet certain requirements like Toronto Green Standard and things like that, where they say the building needs to be solar ready, which just means conduit coming from the roof. And I guess if I was to say I'd like to see changes, it would be more around the versatility of solar products available today, like we see here on this building, solar cladding, or things like solar balcony railings, solar spandrel panels and curtain walls, those sorts of things, and not just solar panels in the traditional sense of mounted on a roof or ground mounted in a solar field.
Well spoken. Thank you. Does the facing with PV rely on adhesive or mechanical fastening to hold backup? Can we take that one?
Sorry, Terry, I lost that one again.
That's okay. Does the facing with PV rely on adhesive or mechanical fastening to honeycomb backup?
Okay, yeah, so the PV facing is adhered to the aluminum honeycomb. And this is really, really important, because obviously there's never a situation when we can allow these panels to delaminate. So the way that they're adhered to the panels is with aircraft grade adhesive, the strongest adhesive essentially available for construction materials. And then in our factory in Etobicoke, Ontario, they go through a vacuum chamber where it goes in and it pulls all the air out of that panel. So there's no ability for the honeycomb and the solar glass facing to separate or delaminate over the entire life of that panel.
Great. Did Mitrex supply the PV roof array at the U of T project as well? Yes, we did. We don't typically provide rooftop solar, but when we're working on projects that are a combination of BIPV and would also benefit from additional rooftop solar, it's certainly something that we can provide. It makes sense to have all solar products in this particular case from one supplier. So in this case, yes, we did. Wow. I think we're done with questions. Thanks, Corey. So thanks so much for joining us today.
Thanks, guys.
Yeah, and learning about the Myron and Berna Garron Health Sciences project. Don't forget to fill out the form to receive your AIA certificate or to request a marketing package. The link is in the chat. So we have some exciting news that we also want to share with you. We will be hosting an in-person on-site tour of this project from July 8th to the 10th. So to RSVP, simply check the description of this event where you'll find the registration link. A big thank you to the project stakeholders and the entire Mitrex team for making today's event possible. At Mitrex, we are very proud to collaborate on projects that redefine what's possible in sustainable design. To learn more about our building integrated solar solutions, visit mitrex.com or connect with us on LinkedIn. Thanks again for tuning in. And a quick reminder, this is the first of 2 LinkedIn Lives we'll be hosting on this project. Our next session will showcase the completed building along with a closer look at the design. So make sure you follow us on LinkedIn so you don't miss out. We look forward to seeing everyone next time. Bye.